All right, guys, let's go over the answers to the practice assignment and talk about how we got them. If we start with this 5 pi over 4, the point on the unit circle is negative square root of 2 over 2, comma, negative square root of 2 over 2. Since tangent is sine over cosine, which is the same thing as y over x, I'm going to have negative square root of 2 over 2 over negative square root of 2 over 2. Now, I could do the whole multiply the reciprocal thing, but hopefully you notice that the numerator and the denominator are the same thing. So anytime you do something divided by itself, that's just 1. And it was negative divided by a negative, so it'll become a positive. All right, for this one, I know I'm doing the odds and then I'll do the evens just because it was easy to copy and paste that way. The point for negative 4 pi over 3 is negative 1/2 square root of 3 over 2. So cotangent is the reciprocal of tangent, which means that it's going to be cosine over sine instead of sine over cosine like the first one. So if I do cosine over sine, that's going to be negative 1/2 over square root of 3 over 2. And I'm going to leave the negative 1/2, but I'm going to multiply the reciprocal. My 2's are going to divide out and become 1. So I'm going to end up with negative 1 over the square root of 3. And then as I talked about in the lesson, you don't want to leave that square root of 3 on the bottom because that's irrational. So I'm going to multiply by square root of 3 over square root of 3, which is a big fat 1, so I'm allowed to do that. So I get negative square root of 3 on the top and 3 on the bottom. So that was number 3. Let's take a look at number 5. Funny enough, this is actually the same, lands in the same place as number 3 did. Notice how negative 4 pi over 3 lands in the same place as 2 pi over 3. That means that they're coterminal. If I'm looking for cosecant, remember that cosecant is the same thing as 1 over sine. So the sine of 2 pi over 3 is square root of 3 over 2. So the cosecant is going to be 2 over the square root of 3. You just reciprocate it. And then again, I end up with the same problem as I did in number 3 where I have a square root in the denominator. So I'm going to multiply square root of 3 over square root of 3. And I get 2 square root of 3 over 3. Okay, so that was 1, 3, and 5. Quick. Now, do you notice that number 2, it was a different angle, but it actually was the same location? So me asking for the cotangent of 2 pi over 3 is actually the same thing as number 3, which was the cotangent of negative 4 pi over. Let's take a look at the evens. Okay, I'm at the same point. I didn't necessarily mean to do that, but they're all asking for different trig ratios, so I think it kind of works out. This time I'm asking for cotangent. I'm going to go. So the answer to that question is going to be the same as it was for number 3. So you could just kind of look at how we worked out number 3 for that one. Okay, this one for 4 and 6, I have angles that are actually bigger than 2 pi, so I wanted to talk about that real quick. It's easy on here to tell what's going on because I put the picture on here, but in tomorrow's assignment, you're not going to have the picture there. You're going to have to kind of like figure it out for yourself by looking at a unit circle or drawing something. So negative 13 pi over 6 is bigger than 2 pi. If you wanted 2 pi to have a denominator of 6, you would need to multiply by 6 over 6. That would be 12 pi over 6. So it's pretty easy for me to tell that it went 1 revolution around. That's 12 pi over 6. And then it went 1 more. So it kind of landed in the same place as negative pi over 6. That's one way to look at it. Another way to look at it, like instead of visually, that's kind of visually. If you wanted to do it with numbers, you would just add 2 pi until you got something positive. So 12 pi over 6 is the same thing as 2 pi. So negative 13 pi over 6 plus 12 pi over 6 is negative pi over 6. You could leave it at that, or you could actually add 12 pi over 6 again, and that's going to give you 11 pi over 6. So this is essentially asking you for the secant of 11 pi over 6. Just to be clear on my terms, negative 13 pi over 6, negative pi over 6, and 11 pi over 6 are all coterminal angles. They terminate at the same place. All right, if I'm looking for secant, that's the same thing as 1 over cosine. And that point right there is square root of 3 over 2, negative half. So cosine is square root of 3 over 2. So if I reciprocate it, I get 2 over square root of 3. And this is going to look familiar. Again, these numbers just keep repeating and repeating. So I'm going to get 2 square root of 3 over 3. I like number 6 because it's kind of a weird one. I want to make sure y'all are comfortable with the strange ones. This one, again, 5 pi over 2 is bigger than 2 pi. So if I do it with numbers, I could subtract 4 pi over 2. Notice on number 4, I added 2 pi. I added 2 pi because I started with a negative. This time I'm starting with a positive angle that's too big, and so I'm subtracting 2 pi instead of adding. So if I subtract 2 pi, it lands at pi over 2. Some people prefer to do it visually, and some people prefer to do it with numbers. Either way is fine. Notice on the picture, I'm going to start drawing. That's pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2. Some people do it that way. The point right here is 0, 1, and tangent is equal to sine over cosine. I know I keep repeating myself, but it really will save you so much trouble if you already know this going into next year, because you're going to use it a lot. Well, sine is 1 and cosine is 0, so this one is actually undefined. And those are all the answers.